Hi listeners, you are welcome to the continuation of our online physics tutorial class from your favorite student ScoreBooster, your online tutorial provider on JAMB, WAEC, NECO and NAPTIP exams. Today's presentation shall be on PAR. I am Bangbade AA. Now, before we proceed, we need to consider the learning outcomes of this particular presentation, which goes thus. At the end of this presentation, listeners should be able to define PAR. Also, listeners should be able to state the formula for calculating PAR. And lastly, they should be able to solve relevant UTME questions relating to power. Now on to PAR. PAR is the rate at which work is done. PAR is the rate at which work is done, or the rate of doing work. Mathematically, PAR equals work done or energy over time. So, PAR can be work done over time or energy over time. Its unit is watt or joule per second. The unit of PAR is watt or joule per second. Now, having understood the definition of PAR, the next thing is to consider the relationship between PAR, force, and velocity. The relationship between PAR, force, and velocity. Now, since PAR equals work done over time, and work done is equal to force times distance, that was discussed in video 9, that work done is equal to force times distance. I urge you listeners to please refer to our video 9 for necessary foundation and work done. For this particular formula, we need to take note that work done is equal to force times distance. So if we substitute force times distance in place of work done in the formula of PAR, then PAR, which is equal to work done, will now be force times distance over time. Force times distance over time. But distance over time is equal to velocity. This was discussed in video 1 under linear motion. I still urge you to please refer to that for necessary foundation on velocity and linear motion in general. But what we need here is that we have to take note that our velocity equals distance over time. Now, the power, which is work done over time, is now equal to force times distance over time, because work done equals force times distance. So if you substitute in place force times distance, if we put force times distance in place of work done, then we have power equals force times distance over time. But distance over time is equal to velocity. If we substitute velocity in place of distance over time, then our power will be equal to force times velocity. So we have to take note of this formula, as we may need it later in calculation, that power is also equal to force times velocity. So from this, we've been able to get 3 different formulas for power. The first one is power equals work done over time. The second is power equals energy over time, while the third is power equals force times velocity. power equals force times velocity. So please let's take note of this. For further calculation we'll be considering later. Now we still want to discuss calculation of power from energy. Having understood the three fundamental formulas for power, that is work done over time, or energy over time, or force times velocity. So we need to also understand the calculation of power from energy. Now let's recall that we said power is equal to work done over time or energy over time. Now in terms of electrical energy, if we can recollect from video 9, electrical energy has three major formulas. We have electrical energy E equals I phi T. Then E, that is the energy, equals I square R T. And lastly, E equals phi square over R. Now starting with the first one, that is E equals I phi T. That is current times velocity times time. Then since power is work done over time or energy over time, then we can calculate power from this formula by dividing it by time. By dividing this formula of electrical energy by time, and that will give us power P equals I phi T over T. So T will call T, and that will lead us to power P equals I times phi. That is power equals current times velocity. Power equals current times velocity. P equals I phi. That is the first formula which we have to take note. Now, considering the second formula for electrical energy, that is E equals I square RT. E equals I square RT. Also, if we apply the principle that power equals energy over time, then we will divide this formula of electrical energy by time T, and that will cut the T we have in the formula, thereby leading us to power P equals I square R. Power P equals I square R. And lastly, if we consider the third formula for electrical energy E, which is phi square T over R. Phi square T over R. Then similarly, if we divide the energy by time T to get power, then that will lead us to phi square T over RT. So T will cut T, thereby leading us to power P equals phi square over R. So these three formulas of power is very essential for us to take note. The first is P equals I phi. That is power equals current times voltage. Then the second is P equals I square R. P equals I square R. While the third is P equals phi square over R. P equals phi square over R. So these three formulas is also essential for calculation of power from electrical energy. Now on to sample questions from UTME. And the first question we shall be considering comes from 1981, number 18. And the question goes thus: the resistance of a 240 volts 60 watts electrical filament bulb is dash. So if we look at this particular question, we need to write out the parameter as the first step. And from the question, we have the potential difference phi to be 240 volts. Then the power P equals 60 watts. Why the resistance is not given. and that is what they ask us to find. So now we need to consider the formula of the power linking P, phi, and R. That is potential difference phi, power P and R. And that will be the formula of power that says P equals phi square over R. That is the formula connecting phi, P, and R out of the formulas we stated earlier. So if we substitute for that, that will be P, which is 60 watts, equals phi square, which is 240 square, over R, which is unknown. So we can cross multiply to get 60R equals 240 times 240. And we make out the subject of formula by dividing both sides by 60. That will give us 240 times 240 over 60. And you can use 60 to cut 240 to get 4. So we'll be left with R equals 4 times 240, and that will give us 960 ohm, making option E the correct answer for this particular question. Now, the next question we shall be considering comes from 1983, number 17. And the question goes thus: a man of mass 50 kg ascends a flight of stairs 5 meter high in 5 seconds. If the acceleration due to gravity is 10 meter per second square, the power expended is dash. So you are given option A to be 100 watts. Option B is 200 watts. Option C is 250 watts. Option D is 400 watts. While option E is 500 watts. Now on to solution. The first thing is to write out the given parameters. And from the question you are given the mass M to be 50 kilogram. Then you have height H to be 5 meter and time T to be 5 seconds. And lastly, you are given acceleration due to gravity G to be 10 meter per second square. Now let's recall that power equals work done or energy over time. Now for energy, the applicable energy to this is potential energy, since they are talking of mass, height, and acceleration due to gravity. Then the formula for potential energy is mgh. This was discussed in video 9 under work done and energy. I urge you to please refer to that for necessary foundation of energy. But in this case now, the type of energy we are having is potential energy, because from the parameters we are given mgh, so you substitute, that will be mgh over time. For us to get power, that will be potential energy over time. So for if we substitute for mgh, that will be our m is 50 kilogram times g, which is 10, then times h, which is 5 meter, divided by time t, which is 5 seconds. So 5 will cut 5 and be left behind with 50 times 10, which will be 500 watts, making option E the correct answer for this particular question. Now the next question we shall be considering comes from 1988, number 44. And the question goes thus: which of the following instruments consumes the highest level of current? Then you are presented with a table with A, where we have electric iron with potential difference 250 volts and power of 1 kilowatt. Then we have B to be television with potential difference 220 volts and power of 110 watts. Then C is a torchlight with potential difference 6 volts and power of 30 watts. And lastly, D is a immersion heater with potential difference 110 volts and power of 500 watts. Now, for us to determine the one that consumes highest level of current, that means we have to find the current from the given power and potential difference by making current I the subject of formula. We have to recall that power equals I phi. So in this case now we are given phi, we are given P, and they ask us to find I. So the formula of power connecting phi, I and P is P equals I phi. So if we make I the current, I the subject, that will make us divide both sides by phi. So we get I equals P over phi. So we now substitute for I equals P over phi for the four gadgets we are given. So for the case of phi now, our I equals P over phi, and that will be P equals 1 kilowatt, which will be 1000 watts. 1 kilowatt equals 1000 watts, then divided by phi, which is 250 volts. So 1000 divided by 250 will give us 4 ampere, making the current for it to be 4 ampere. Then for B, we substitute similarly for I equals P over phi, and that will be the P for B is 110 watts divided by phi, which is 220 volts, and that will give us 0.5 ampere. Now similarly for C, when we substitute for I equals P over phi, the P for C is 30 watts divided by phi of C, which is 6 volts, that will give us 5 ampere. And lastly for D, I equals P over phi, and the P for D is 500 watts divided by phi, which is 121, which is 110 volts. So that will give us 4.40 ampere. Now, out of all these, the currents of A to D, the highest we have here is C, which is 5 ampere. Which is 5 ampere, making option C the correct object, being the highest current we have. Now, question 4 comes from 2006, number 14, and the question goes thus: an engine of a car of power 80 kilowatts move a rough road with a velocity of 32 meters per second. The force required to bring it to a rest is dash. So you have option A to be 2.50 times 10 raised to power 6 Newton. Option B to be 2.56 times 10 raised to power 3 Newton. Option C to be 2.56 times 10 raised to power 6 Newton. Then option D is 2.8 times 10 raised to power 3 Newton. Solution to this: the first thing is to write out the given parameters, and we are given the power to be 80 kilowatt. That will be 80 times 1000 watts. That will be 80,000 watts. Then we are given the velocity to be 32 meters per second. For this particular question, we are going to use the formula power equals force times velocity. So, and in this, we can make force the subject by dividing both sides by velocity to get force equals power over velocity. So when we substitute, the force will therefore be power, which is 80,000 watts divided by velocity, which is 32 meters per second, and that will give us 2.56 times 10 raised to power 3 Newton, making option B the correct answer for this question. Now on to sample questions, practice questions from UTME. And the first question comes from 2009, number 10, while the expected answer is option C. The second question comes from 2015, number 29, and the expected answer is option D. Our next video will be on calculation of the cost of energy consumption with sample questions from UTME and its solution. I urge you to please subscribe to our YouTube channel, like and share our videos, as we promise to provide you more interesting lectures on subjects related to UTME. Thank you.